We're very happy to have Sinan Eren here from Immunity. And Sinan, he's worked there since 2003. He's a VP of Research. And before that, he's Senior Research Scientist with Intercept. He's an expert at finding new vulnerabilities and developing state-of-the-art and exploitation techniques. His specialty lies in the analysis and exploitation of operating systems, service software, software infrastructure applications. Recently, he's been focusing on hardware-based and alternative attack techniques. So today, his presentation is titled Information Operations, which I guess is a nice play on the Immunity name there. And he's going to discuss some new attack techniques to attack secure networks, such as client-side attacks, application backdoors. And so very happy to have you here.
Thank you. Hi, thanks for having me. Well, information operations, let me put up the slides. We actually first meant it to be information operations, but some folks that we know from intelligence backgrounds thought it was a gross misuse of the term, so we kind of come up with this play of naming it information operations. So as the flattering explanation I think probably put together by Dave, I try to take care of the research Immunity. We're a small boutique security firm that does offensive technologies, that build offensive technologies. Our main product you might have heard is Canvas. It's a penetration testing framework, but we also try to develop other tools, standalone tools, hardware-based technologies, but mostly focusing on the offensive side of information security. So today we'll be talking about a real-life scenario, which is I'll try to differentiate why is it different than a typical pen test that we conducted with a corporation, which is which we will call it as a high-value target and leave it at that. And it was a long-term operation. It was a long-term scanning, testing, and it involved building technologies specific to that customer attacking their network. While we were conducting this assessment, which again we called information operation, just to differentiate between the typical pen test that's been conducted these days, for a while. So we came into unique challenges about how to attack this network, and it involved using. There's a problem? Okay, thank you. So there were some unique challenges about this network. So we came up with certain technologies just to work these problems around. So one of the major differences between a typical pen test and what we conducted towards this company was a long scale operation. We could say on and off it was about 3 months. Yeah, we went on with our daily duties. It wasn't like full time all day, but we had to set up certain exploitation vectors. We set up custom backdoors and stuff, and we did a long time data collection, and we had a internal and a quite large scope of targets that we can attack and identify. It was obviously a different type of contract. We knew these folks on an executive level, and they were on board pretty much most of the time. And the time there was no specific time for a start and an end. That was just a goal, and we were to come up with the terms that says whether we achieve that goal or it was unachievable. So again, the differences between what we like to call information operations and a pen test is that we did not have any time limits, and we were able to collect data over a large scale of time, that data involved a lot of information about who works at what department, who does what. Some of them open source intelligence, looking at mailing lists and whatnot. Some of them came directly after exploitation. So we'll get into details of these. But first, we started with a mindset that differentiated from typical pen tests. We decided on not to do extensive scans. That we weren't going to run mmap scans. We weren't going to try to fingerprinting operating We weren't going to do all these typical things. This was a corporation with a security department and with people on board that dedicate their full time on network IDSs and all the typical stuff. So this is a funny graph from Dave. Well, it tries to symbolize is that you have a security department, you have a security budget, and it's the gray line that's going up and down, and the red one is the attacker. And then at some point, as you can see, the red line goes over the gray line, and that's the time, well, where you want to be at and where you break. And it's just another fun intended slide, so I'll move on. So our model in mind was not to find out what's out there. We knew that certain things have to exist: a web server, an MTA server, a mail server, a DNS server, some border, routers and firewalls and VPN devices, whether it be applications or software, hardware or software based, and then of course the endpoints, which we had no idea what they are. So, clients, basically client operating systems. So we know that these things exist. They're easily gatherable from open source intelligence. You do NS lookups, and you do basic sorting queries and learn about where the MX records tells you the mail server and all those simple things. So we identified about 4 or 5 different machines that were just doing basic queries, and we did not pick on the web server. So again, a typical penetration testing involves around looking for known vulnerabilities. They scan networks, they look for operating system, identify them, they look for ports, they look for applications, do some extensive application level fingerprinting, and they check these informations against hotfixes and patch levels and all that. But the recent, I would say, I don't know how recent, but probably last 3 years or 4 years, there's more focus on the web applications. But yes, if you're a financial corporation, yeah, web applications matter. There should be pen tests towards these web applications. But if you don't have if you have a static dry content on your web server that does not do anything, I mean, let's say you're in the aerospace industry. I mean, what your web page doesn't hold really anything interesting. And in this case, our client had his web server on a hosting company. So we weren't really interested in hacking into GoDaddy and whatnot. So it's just dry HTML content without any useful logic, and they run on Apache. So these are hard targets, and if you want to directly attack the application itself, these are well-known players out there, and they've been audited, they've been looked into for a long time. So we did not pick on the web server. We did not pick on the infrastructure. Yes, I mean, you're hearing about great research being publicized about hardware. We do a lot of reverse engineering and trying to exploit the hardware devices as well in the research labs. But these are usually really costly equipment. You can buy Cisco routers over eBay and whatnot, but a real-world router you're targeting is way beyond your budget. So these are costly lab setups, and there's a lot of firmwares out there. There's a lot of iOS versions. There's a lot of PIX versions. Even you ID a bug, there's no guarantees you're going to write a exploit that is reliable and that's not going to give you away. So again, another goal in mind was we wanted to be really stealth. We wanted to do this right. There are a lot of things that are known but not really addressed. Is that there's these things you read about the targeted attacks coming from other countries and all those. So when it's other countries or rogue players out there, these things are talked about. But the thing is, these things exist. 0 days exist, and this is the reality. And there's targeted attacks out there. People, focus on your infrastructure, find a weak link, and then use it to leverage their penetration. So we wanted to mimic that, basically. We don't want it to do a compliance scan on the network. We didn't want to say, you have your hotfixes there, you didn't have those, you have a SQL injection there, and this. We just wanted to mimic a real adversary out there. Again, we skipped the VPN and the firewall. We couldn't even ID what they were, and whether they're hardware-based or software-based, these are really costly and tough applications to attack. So typically, you'll pick on the endpoint. You pick on the client sides, your IEs, your Acrobat readers, your Outlooks, and all these stuffs. But this is somewhat blind. You do some open source intelligence, again, from mailing lists, from corporate information from LinkedIn and all those. You gather, let's say, 500 employees or something like that, and you just wanted to spam these guys emails for a client-side attack, whether a known client-side, where there's zero-day you develop. But this is really easier to detect by a smart opponent, and it's easy to burn a zero-day. So you have a good client-side attack. You invested time in it. You attacked, and one of these failed because of an endpoint security software or because just sheer bad luck, and then it's easy for them to recover from that point on, and it leaves a lot of traces behind. You email all these things. You know, once they hit the exchange, you have a lot of fingerprints left over there. So this funny graph again tries to show you that when you're using client sides to attacks, you're usually in that yellow area. So we try to avoid that. We wanted to gather more information about our network than we thought about maybe leveraging further access with using endpoint exploits, client-side exploits. We picked the mail server. So why we picked the mail server? Because it is guaranteed that there is valuable intelligence on the mail server. It's your mails. It's your most important software application that connects you to the outside. And especially for this client, mail was more interesting than any other medium because it's your clients, it's your suppliers, it's where you buy, where you get support, where you buy products, where people who sell your products. And it's one machine. It could be load balance, it could be all those, but after all, it's one software. So we picked on the mail server. We did not do any scans. We did not do any large class scans to identify, as I say, the network of this client. We did not do even a port scan on the mail server itself. We know that port 25 is going to answer us with at least some SMTP protocol replies. Maybe it will print the application banner or not. It could be disabled. So in this case, they had the banner on, the application banner on. But then again, we thought about this problem, and we put a tool in Canvas that basically does a bunch of bogus SMTP queries, retrieves responses, and we have a large database of MTAs that it cross-references the responses, the SMTP responses, and try to identify what MTA is run on the other end. So the MTA gateways are fundamental. I mean, they are there. You have to do something about malware. You have to do something about spam. So there's an AV running on pretty much every large corporation and every high-value corporation's mail server. Whether it be a plug-in to Exchange, whether it be some AV vendor's gateway that basically receives the email, does some scans, and then forwards it to the Exchange or SendMail or whatever else you're running. So we call this the soft direct approach, and we download the software from the website, put it apart. It's much easier than trying to attack operating systems at this point. You know that they know about network filtering. You know that they know how to use their firewall. There is no point in for you to going and investing time into the TCP/IP stack of Windows Server at this point. They have a gateway. They run an AV. And AVs are traditionally known to be quite badly written in many aspects. So we downloaded the software. We found out what AV it's running, what AV software it licensed, and we knew from past that there's a lot of issues in file format parsing in AV engines. And what the surprising part was that the software was restarting no matter what. It was handling pretty much every exception, and even things went really bad, it was automatically restarted by a watchdog. So that was a good start. We knew that from that point on, even if we have failed exploitation attempts, we will have as many chances that we get attacking the software. So we model our target as best as we can. We installed server operating systems from Windows 2000, 2003, all the service pack levels and whatnot. And we did this with VMware, of course, but at the very last moment before we run our attack, we did some tests on real Eren for the reasons I'll explain later. So again, when you're doing these kind of target attacks, language detection, you might the operating system language, the locales might be an issue. But at this case, we knew which locale they were in, basically English. So there is, if you look back into the history of these exploits, and there has been tremendously written exploits out there, like the SSH exploit of some years. These were written in a way that they did not take into account what the Linux distribution was out there that they were targeting. They were written in so much effort and so much time was put into them. They were basically working on every version or every possible installation, because there was a lot of amazing brute force logic put into these exploits. We did not want it to take that route because it takes a lot of time. You need to pretty much dedicate one person on writing these exploits, and pretty much it's a development effort that takes several months. So we wanted to instead extensively model our target in our lab. So we wanted to make sure we knew what operating system, which service pack, whether it's an AMD 64, whether it's an Intel 32-bit machine. We did as best as network identification, using mmap and all these tools and some build and other canvas tools. Just try to build up the final target machine as best as we can to replicate our target. So another interesting thing about this AV gateway, AV spam gateway, was that the crashes, the logs, when the watchdog started to crash MTA process, it was really vague. There was no information out there. It was just say it's suddenly terminated and then restarted by the watchdog. Pretty much it. Nothing about. There's no back traces. There's nothing that gives out that there was a failed exploitation attempt. So again, the most interesting thing, and probably the most futile thing about AV is that we find out pretty much all the other AVs that we did research as well, that they were breaking Microsoft latest technologies that they put into Microsoft operating systems for exploit resiliency. They were breaking DEP, the non-execution for writable memory areas. They were breaking safe SCH because they were loading all kind of DLLs that were not compiled with, they were compiled with Borland basically, because AVs carry a lot of excessive baggage from old times. They wrote unpackers that they only compiled with Borland back in the time. They have third-party decompression libraries that are licensed from third parties, and these are compiled with 1995 with Borland's something, and then these are directly linked or loaded into the process. So they break safe SCH. And also another fun thing that we found out, that Borland, when you compile their part of their source or their whole source with the Borland compilers, it comes with Borland's own allocator, and that's a terrible mess. It even corrupts itself at times, without giving you any source of idea what went wrong. And it was the easiest heap allocator to exploit that we ever encountered. Microsoft put into a lot of work with the low fragmentation heap and all these things into Vista and probably in 2008, but these things were not in the MTA gateway in the AV process because they were using the Borland's allocator. We did not find any stack overflow. I'll get into details about the overflow itself, but if we did find a stack overflow, there was no GS as well, since it was the stack cookie protection, since it was compiled with Borland. We found heap overflow in an unpacking of a certain file format, and also again after this assessment, we did a lot more research into AV, and AV engine seems to be the champions of typecast and overwrap bugs. So there's a lot of they usually limit the size to shorts when they're doing read operations and whatnot. But then they have a terrible track of doing stuff like this, that they add a bunch of header and subsection sizes, and then they typecast it into a short. Obviously, it's 64K, and after all these additions, it might wrap to 0 or something smaller, and then they use the subsection sizes or the block header sizes and all those things later into the read IOs. Also, there's other typecast-related issues that I didn't put down here. But for example, they might read in a total size from, again, the file header somewhere. They can allocate that much, and then they can read in using a subsection size. You know, the binaries could tell you some total size, and that is just 10, and the subsection size can be 200. So they don't verify these things really well, and these are pretty well known actually. Alex Wheeler has done a lot of research, and this vulnerability that we find out also later turned out to be also found by him, and it was taken care of later on. So at this point, we had our heap overflow. It was corrupting the Borlase indicator. We had the easy way of exploiting it. And the exploitation vector was pretty straightforward. It's just an email attachment. You can send it to a void user. It doesn't have to be a legit user. And the email is scanned no matter what, and then it's silently discarded. There's no traces left. Okay, and as I mentioned, the DEP was disabled by the product, and even if we had failed exploitation attempts, it was restarted later on. And we did fail when we attacked a bunch of times, but eventually, remember I mentioned the real Eren? We first developed this exploit on VMware, and we keep failing on the target side. We installed it on the real Eren, and then we found that there was some discrepancies between VMware and the real Eren, the real hardware. If we fixed it, we tried again, and we were in. So most of it's a technology that is part of Canvas. It's basically a shellcode technology. And after we wrote our exploits for this MTA gateway, we first break in using the Canvas technology. But then we wanted to use this. Usually a typical pen test might call it a day and then write a report and be done. But we had again, as I mentioned, different mind and say we did not have any strict timeline. We did not have any restrictions on what sort of data we can access. So at this point, we sit down and develop a quite easy custom backdoor. Since you're on the MTA gateway, and since you're breaking into the AV, you got every email basically. The AV process is handed out just a file, which is the email itself. So we thought about, okay, let's log all these emails, and then later, you know, we'll collect them. So we're at a typical custom backdoor that does two things. It was it was taking the emails. But of course, we hooked the AV process. We hooked this backdoor DLL into the AV process, which was getting a copy of the file that was being scanned. So we and Microsoft has this wonderful DLL, the cabinet DLL, which stores files into a cap file, and then it rotates them automatically. So we didn't really have to have elaborate file compression and file storage-related problems. We used what Microsoft gave us. It was a quick development. Again, we logged emails into cap files, and we scanned emails for a special trigger. When we see that trigger, we were again sending out a mostf shell, which later we used to collect these emails. We did quite a long time of email collection. Again, I have to say that the executive level guys were on board with us, and you know, we have certain limitations of what can we do with these emails and what parts we can look into, but looking at the headers and the attachments were pretty much enough to analyze and to find out more about this network, more about this corporation, who was sending emails to who, what type of attachments were coming in and out. And we were mapping the soul trust relationship pretty quickly and about this cross networks that were going back and forth and exchanging executables at some points. So we wanted to breach further. We're on the DMZ right now. We are on the MTA itself. So again, we just exploited trust at that point. We just injected what we now call Pink. Back then it was just a prototype, another custom backdoor that we developed, which I'll talk later on. We injected Pink into just an attachment, basically. There was a bunch of attachments going back and forth, and we did not use any client size. We thought we might have some use for them after we figure out the internal network, but it was much easier than that. So we broke from the DMZ into the endpoint, into the client network, and from there, you know, I'm not going to go into details, but from there we leveraged further into the primary domain controller using a well-known DNS RPC exploit, MSRPC exploit. We obtained a domain hash, and then we use the domain hash into installing mostf nodes. Again, the Canvas technology that talks over HTTP to the outside, and we install these into a bunch of interesting desktops that we identified, again, reading email, looking at the emails. So we knew which guys were the interesting guys. We knew which guys hold the key to the kingdom. So using the domain hash, we targeted just these individuals strictly. So one machine that we were really interested in, that they were emailing out a bunch of attachments from the desktop machine. So we broke into that machine using the domain hash, and we see that there was traces of files that were interested. That was the actual target itself that we had in mind, but they were not there. So there is this file called setup API log, which keeps track of all the USB hardware that's been plugged into your device. And we see a lot of extensive logs in the setup API log that indicated that there was heavy usage of USB drive, USB mass storage drives. And at that point, we assumed that the files that were listed in the recent accessed files folder, that they were in the USB drive. So the assumption was that there's a USB drive, storage drive, that is going between some other network, some segmented network that has these files. Again, from the email collection on the MTA server, we found out there's a third-party vendor that is in touch with this client, and then they're exchanging information about the product they purchased from this third party. So we remember that there's this tool written by a bright French guy, really bad with the name right now. It's called USB dumper. Basically, it just sits there and then waits for an insertion of a USB drive and copies the files and then emails them out. We didn't want to do that way. We took USB dumper, we modified it into an in-memory injection, again, a DLL trick that we already use on the MTA. We had some file tracking to it just to make sure that we don't keep copying over the same file over and over again. We had some free disk space tracking to the software as well. And again, time passed. Finally, we were able to reach to some data that was supposed to be segmented. That was supposed to be an air gap between these two networks. But because of this tainted USB drive going back and forth in these two networks, we were able to access to some high value content for this site, and we called it a day. That was pretty much the end of this operation that we now name information operation. So some conclusions. Again, these are crucial software. You need to run these spam and malware, AV gateways and antivirus software and all that. But they're terribly written. That's the reality out there. There's a bunch of guys from Enron's, a company from Germany. They gave some presentations about their findings. I guess probably over 40, 50 bugs that they found in various AV vendors in 1 year, just in 1 year. And this whole problem about writing parsers, more and more parsers to protect applications, to protect protocols, is just turning out to be a terrible idea. Instead of securing it on the protocol itself and the protocol's actual application itself, you keep writing more parsers on top of these protocols. So AV is I believe one of those things. There's a lot more parsers than put into AV than any other software you can imagine. There's different type of compression algorithms that they deal with. They deal with all type of executable formats. They scan for ELF binaries, Mac binaries, Mac OS 9 binaries on a Windows operating system. For what reason? You know, it's another attack surface that is really wide. To be honest, they are a major security risk instead of being an instrument of protecting against malware. And again, some other conclusion that we come is that tainted USB drives, which we call tainted because it goes between two networks that were supposed to be isolated by an air gap, could be a big issue. I heard from some folks that work into high security networks that they color code their USB drive. So that sounded like a solution to this potential security breach. So there's a color coded USB drive that can be worked on one network. There's another colored USB drive that's only allowed to be plugged into one network. Of course, human will still do mistakes, but at least that could be an interesting way out. Also, we learned from this that relation mapping between people are crucial, of course, for successful breaches. But also relation mapping between what files goes between which networks, which users send which files to each other, and all these other details about email content that needs to be put into these attack frameworks, into these attack toolkits, that we have to now have this complex understanding of these trust relations, not just who emails who, but who emails what to who. So during this assessment, why I talked about this assessment is that during this assessment we developed a bunch of technologies, and that we developed into further access elevation and penetration tools, and then we put it into Canvas. So one of these technologies we named Pink is a post-client-side exploitation tool. So there's this problem about, let's say you break into 10 client sites. Okay, easily manageable. You break into 100. You break into millions. So how do you control these networks, and how do you handle these penetrations? So a lot will call these drones, and they are now part of botnets, and they're well-known technologies that are used to control and command and control these botnet networks. I think Dave Dittrich and Bruce Deng gave a talk about this yesterday. I mean, if you attended, you know more about these than I do now. So they're usually control vectors. The control and command technologies are based on IRC. Which is easy to tear down, which is easy to take over. You can just make a call to the ISP and the network is down, or you can just go ahead and take it over. HTTP to a single server is another problem. Just once the drone or the backdoor is detected, it's reverse engineered, the IP is extracted, and then you can again take over this HTTP server that the drone network talks to. There's this whole fax flux of DNS servers and all that. Again, these could be easily blocked. And the other one, which seems to be gaining traction, is the P2P storm networks and all that stuff. They are really reliable. They seem to work pretty well, but then again, they're not covert because the TCP traffic of these P2P protocols, and they don't usually go through strict proxies and firewalls. So our solution to controlling our own command and control, creating our own command and control technology, we had three goals. It has to be scalable. We should be able to categorize these drones into groups. It should be covert, and it should be portable. So we came with Pink, and this is what simply the Pink technology looks like. So once you break into the cloud of targets and deploy your Pink executable into them, the way of these drones talking back to the command and control server or the master itself is through blogs. So they go to Google's blogs, and then they search a special keyword that is embedded within the backdoor, and then they look at all the output, and they scan the output for a certain pattern. When they found a pattern which we call dead drop, they verified the contents of the pattern using RSA key signing and then verification. And based on what's inside this blob, inside this dead drop blob, they do certain things like talking back to a listening post, uploading file, downloading more files, executing commands. So currently in the Pink technology, we use blog searching as the first way of finding the master, the command and controls network's master. The reason why is simple, because the blogs are indexed instantaneously. You just put up a blog post, it's right there. It's easy to find, all these blog sites. We currently use the most popular one, theblogger.com. There's a lot of things to hide into. It's HTML, basically. You paste your blob into it. You put the HTML comments into it, so it's not really visible when you look at the site. And there's RSS feeds, which are also come really handy for a development point of view. And the next thing we do is that We found out that WebSense is a really commonly used technology, and they tend to sometimes block access to blog sites. So there's a fallback network. We fall back to Google's main search site. So if we don't get anything, any response from the blogger site, we fall to Google, and then we search again for a certain pattern that is embedded into the pink the DLL itself, and we browse the results for a special dead drop, for a special blob. That's pretty much how it looks like. There's a cover text. It could be anything you want to put there, news and whatnot. There's a trigger that the ping DLL searches, and when the trigger is found, there's a base 64 encoded stream, and this base 64 encoded stream is encrypted by an RSA, is signed by an RSA key. So ping verifies the signature, and if somebody's trying to take over your drone network, we thought of that might be a time-based key might be the way out of that. So we sign and encrypt. RC4 encryption, we use that, but it's pointless, I guess, because the key's inside the DLL itself. But the signature can prevent a lot, from takeovers, from replay attacks and whatnot. Also, we use random words for our search queries. We use the daily news, what's going on in the time of the exploitation attempt, and we create blog entries regarding these common news. Okay, so I'll get into some technological details about the backdoor itself. So we had the problem of not really knowing. There's a wide stream of operating systems out there. It could be an XP box, even on the Microsoft scale of things. You might have admin privileges. You might not have that. You might have a different setup. So we thought of using a shell extension as a way of being persistent on this client box. The Y shell extension doesn't require admin privileges. You just add it to the current user's registry key. It's persistent across reboots. It just requires an Explorer action like a click or a drag and drop or right click and copy paste. All these things activates all the register shell extensions. We use some simple technology that takes the DLL itself out of the PB loaded modules list, which means that when you go into, let's say, Process Explorer from sysinternals, you don't see the DLL inside the process. It's partially invisible in user mode, but of course it's in the registry. So we didn't go into details about writing a rootkit to hide the registry and stuff, because it's a never-ending game, because rootkits can be detected and whatnot. So at this point we said, okay, the registry traces, we'll leave it at there. We picked up some funny name that goes with the shell extension that sounded quite legit. Also, we picked a shell extension for the way of keeping our backdoor persistent, because we don't know any AV product that the ones that we looked into, they don't really check for this. They check for the startup folder, they check for the run keys, they check for creating a service, they check for all sort of bad files that are being executed and whatnot. Or they check for the boot order for rootkits and other backdoor technologies, but they don't look for shell extensions, at least at the moment. And again, as I said, once you install this shell extension into the registry, after a reboot or a logon, all it takes is just a click or a drag and drop or a copy paste operation for it to get activated. Personal firewalls might trigger on Explorer EXE doing an outbound connection, because it has to go to the blogger site to do the search and then look for the dead drop. Doesn't seem to be a problem on the default firewall that comes with XP, but there's a lot of personal firewalls out there on the market. So we did not have a solution for all of them, but it's easily doable. In the sense that you can inject it into another process, you can inject it into an Internet Explorer and whatnot. There are ways that you can do the same type of trick with the Internet Explorer. You can use browser helper objects, but a lot of AV products and personal firewalls and malware-related products check for browser helper objects. So we stick to the shell extension, And we know some personal firewalls might say Explorer.exe wants to do outbound connection. There's three components to the ping technology. There's ping.dll, and there's the ping installer, which the DLL is embedded within. And then there's the blog content generator, which basically RSA signs your commands and then wrap some triggered text around it for you to just paste on a blog site. So we thought of ways for categorizing subsetting our drone networks into certain groups. It could be about corporation. It could be a certain domain would be anybody coming from immunityinc.com would be on a certain group, or from a country could be another subset. So we wrote some simple web application that combined the ping installer's backend with GeoIP. So basically, this is what it looks like. You send out a client-side exploit, let's say a PDF Acrobat Reader exploit, and the exploit has a simple download and execute shellcode in it, which is a common trait in client-side exploits. It goes to a web server to download the ping installer executable. The ping is when it asks for the ping installer executable from this web application, the web application talks with the GeoIP backend and then sends out a specific ping installer based on the IP address that the client is coming from. So each ping installer searches for a different pattern, which is answered by a different blog post. So the goal was, to be able to divide our drone networks into countries and companies and domains, and based on time of exploit, it could be any parameter you like. So we wanted to do things like the following: all hosts from immunityinc.com domain go to this IP, and just give us a shell over a canvas, most of technology. Again, some little more details about the ping technologies. That there's a timer. It does these master command and control master searches on blogs on a configurable time. The timer expires. The ping DLL, the ping executable looks for some user mode action. If there's a keyboard activity, there's a mouse activity, it does go to the internet. So we don't want to do outbound connections at 5 a.m. or 3 a.m. out of a corporation. So we wanted to always check there's a logged on and active user. If there's no user activity, we start sleeping on shorter time intervals, and when there's user activity, we do our blog and Google search, depending on which one is allowed. So these are some of the ping commands that we currently support. We do callbacks to Canvas over HTTP and HTTPS streams. So you're behind a proxy. We do speak HTTP with our drones. If you're in a more open environment, it can do just a TCP connect back to any listening post out there. It can download an executable from a URL and execute it. It can download a DLL from a URL and load library it. It can execute the given command. It can upload a file into a web server and an FTP server. It can do key logging. It could update itself. And then we're thinking about using Microsoft VB scripting engine in order to write more complex commands. So to conclude, what we did with ping is it's in beta state. It should be shipped out in the to the mainstream Canvas users in the next build, I believe in 3.0. So what we're trying to achieve here is that we wanted to look further into this whole offensive technologies and whole drone networks and see how far we can take it. So it is going to be harder to detect these things, these technologies. It's going to be hard to monitor these things by automated solutions. A lot more, you'll see a lot more search engine uses for command and control networks, and the best part about it that they don't require any expensive infrastructure to manage your drones. You basically put up a post on some blog, and actually you might even take it to another extreme. You can have your commands that you put up on a blog post returned to you as a blog comment. So you would have basically no infrastructure needed to control your drones. So as overall conclusions, information operations proven itself in a different way than what Pentest does. The MTA was compromised. The endpoint was later on compromised using the trust. The air gap was breached by just using a readily available tool on the internet. And from this, we come up with a potential solution for the client-side exploitation and command and control, the scalability and the covertness of this whole operation. So there's a different reality out there that there are more and more targeted attacks. The trend was sending out millions of emails with well-known client sides, even at points 0 days. But now attackers are focusing on more 0-day per target like attacks, and we're going to see more and more of these, and the technologies that are used to further leverage your access is also going to be changing in over time. So why I'm saying this is that there's not going to be a solution that will detect and automate this problem. So you're not ever going to have the $300,000 pizza box sitting on a network that is going to tell you that there is a target attack, there's a 0-day attack, there is this covert command and control drone that is coming out from your network. It's all about the human at this point. It's all about training a team. It's all about hiring and training the right people. Investing on more in human capital. That is going to be the only way out in the next coming phase of things. And being on the offense, attacking your own applications, attacking your own network is going to be key for survival. So I met one CSO. I was amazed with her insight about this. That at that point she was working for a large financial corporation, and she had amazing reverse engineers, exploit writers on board hired during her tenure over there. So this is the type of proactive stance that a lot more big corporations, high value, potentially high value content providers have to take into action, into mind. All right, thank you very much. I have a demo, but I think I'm just running a bit late.
Yeah, I think we're.
Yeah, 50.
I think we're just out of time.
All right. Thank you very much.
Okay.
Appreciate it.
I have a few sheets back here.